One thing that probably occurred to you very quickly, even just getting the first record or two up on the screen with this, is the idea of typing in the type of mask, of entering that value into the screen. Picture you're going to put a lot of data in eventually, right? And, it's a situation where, sort of a category or type like this, it's sort of like an option. Wouldn't it be much better to choose it, okay, out of a drop-down list or something like that, rather than having to type it in over and over again, run the chance of, typos or mistakes, N93 instead of N95, and oops, I didn't mean to type that, but now your data's all messed up, right? It's much easier to select it than typing it every time. So how would we implement that change? Well, we would need a separate entity then for the actual category or type of mask, right? So let's come to our models folder. We'll add a new class here. We'll actually call it the same name we were using for a field there. I'm going to call it mask type. And just to save a bit of time, no point watching me try and type things as you've seen already. So I'll just copy paste here. Here's my mask type, right? So it has my int ID, my primary key, following that naming convention, a string just for the name for the mask type, right? Some data annotations here that's required. Then we have a display name, type of mask, and putting a maximum length on it, similar to what we did before. Ooh, this is exciting. This is something new. Since we have a mask object defined, right? These are set up in a one-to-many relationship, a parent-child relationship. A mask type, okay, is the parent, the child is the mask, right? So the mask type is on the one side, the mask is on the many side, right? So as an option, we don't have to have this, right? The system would work fine and the one-to-many relationship would work without having this collection up here. But it's a convenience for us because when we later on go to select mask types, right, we can actually include all of the actual masks in that type, all the children that are related to it. So we're going to leave that in place. Coming back to mask, to finish relating these two together, we have to make some changes here. So right now, this string for mask type, I might as well get rid of it because I'm not going to need it anymore, right? Instead, what do we really need? Well, think about it from the database point of view. What do you always have in the child, right? In the child side or the many side of a one-to-many relationship, you have the foreign key. Now, the primary key technically here is this integer identity called ID. So it would kind of make sense that we might have a mask type ID as an integer for the foreign key inside the mask table, but that's fine in the database. In the object-oriented world that we're working in right now, what we really want to have, and actually the only property that is actually required to make this work, would be to have a object, a mask type object in here. I didn't mean that tab, I wanted a different tab. There we go. So a public mask type, which I'll just call mask type, right? Technically, that's all I needed. I didn't need that collection in the parent, and this is all I really needed in the child, right, in the many side of the relationship, in order to define the relationship as far as entity framework is concerned. However, we know that in the database, it's not going to store an object here. It's going to store that foreign key, that integer value. So we might as well take control. The system will automatically generate its own name for whatever it wants to call that integer foreign key value. I like to be in control of that. So typically what we'll usually do is I will add two properties on the many side or child side of this one-to-many relationship, one for the actual object and one for the foreign key, right? For the actual integer that will relate back, okay, to the integer primary key on the one side of the one-to-many relationship. And following the naming convention, I just have to say mask type, the name of this class, ID, well, actually, technically, it's because this is a mask type, right? And then it knows right away that, oh, that's the foreign key. I could use a data annotation to indicate this was the foreign key if I didn't want to follow the naming convention, but I do like to follow the naming convention whenever I can, right? So I have a display name, type of mask, right? I have the required attribute to say that, no, I have to specify the type of mask, and away we go. Notice I can have the same display name here on mask type as the object, right? That comes in handy depending on which view you might be showing. Okay, this property, you might be showing this property, right? So it's good to have, and you're allowed to have the same value for display name on multiple properties. So that will not cause a problem. Okay, so now we have all three properties that support. Okay, the only one that's absolutely required is the object, right? The mask type object contained in the child, the mask. Okay, but we have also the foreign key, and we have the parent in the parent object, the collection of the child objects as well. Okay, that's everything in place there. Okay, now one other thing we might want to think about. I mentioned earlier that we have our naming convention, we have the data annotations, but if we want to further refine the model, one of the things that we'll often resort to in the end, if you can't do it with either of the other two, is that Fluent API, right? And that is where we're going to actually put into place a restriction. Right now, a standard approach for a one-to-many relationship is if you delete the parent, well, referential integrity would say, well, no, you have to remove all the related child records as well, right? Because they can't be orphans, right? They can't be without a parent, so you'd have to remove them from the system as well. So the alternate is to say, no, that cascade delete, we're not going to allow that. We're going to restrict it. So you're not allowed to delete a parent object if there are any related child objects, right? Now to go and do that, we'll have to make a couple changes. We needed to make one at the very least anyway, right? So let me just save everything so far. Come to the actual DB context, and here's our mask context. So we haven't done much work in here for a while. One of the things we obviously need is we need our DB set. Oh, DB set of mask type called mask types. Okay, that's good. All right, so now we have our two DB sets that we can work with directly in our DB context. But that's not all. What we're going to do is we're going to add an override for the on model creating. And that's where we get to put in anything that's considered part of this Fluent API, right? So what we want to do is we want to prevent cascade delete from mask type to mask. Okay. Now I'm going to write this from the parent point of view. So from our model builder, we say entity mask type has many objects of type mask called, okay, or referred to as the masks, right? That's the name of that collection of masks inside of mask type. All right, with one parent object, the mask type, has foreign key. There's my mask type ID. On delete, delete behavior, this is an enumeration, will be dot restrict, right? And that is how we define it from the parent point of view to say, no, we're going to restrict. Okay, we won't go to allow cascade delete, right? By the way, that is another one of the enumeration values here, right? It would be cascade, right? And so on and so forth, but we're going to go with restrict. Now, I just want to point out that you could, and it makes no difference, that is written from the parent point of view. You could actually give the exact same restriction from the child point of view. In that case, you'd write it this way, okay? From entity mask, right, has one mask type with many masks, and then so on and so forth. So, it doesn't matter which one you do, whether you define it from the parent point of view or the child point of view. I mention that now because sometimes it can be confusing when you see code online written one way or the other. You think, oh, wow, does that make a difference? Now you know it doesn't, right? Because it's the same relationship. It doesn't matter, there's somebody at each end of the relationship, the one side and the many side of the parent and the child, right? It's the relationship we're talking about here. So we're restricting cascade delete, right? And we aren't going to allow that to happen. Okay. So we've made a number of changes to our model now, right? We've added our mask type entity. We've modified mask, so now it uses this foreign key value instead of typing in the mask type. We've even added the new DB set and this restriction using the Fluent API in our on-model creating, so you cannot delete a parent object if they're related child objects. Well, clearly we're going to have to do a new migration, right? Can we do a new migration? Well, let's find out, right? So, by the way, before I go on, something I usually encourage students to do, you've seen that we've been able to pull up previous commands a few times, right? But that's okay for the session. What if I close Visual Studio and open it again? And it's the kind of thing you might have to repeat these commands more than once, because sometimes you can't just make a new migration. You have to start a fresh set. So what I'll often do is right in the data folder, I'll right click, I'll add a new item, just a general text file, right? And I don't know, I might call it something like common commands, something like that, right? And inside that file, I will put the things that I commonly find myself typing over and over and over again, right? So there's my initial add one. Okay, what else did I sometimes do here? My update database and so on. So I'm just going to save all these in this little common commands file. And, other things that I find I'm repeating myself with more and more often as I'm working in Visual Studio, I can throw in here as well. You can put subheadings and organize this to your heart's content, right? Okay. All right, so I'll just save that. I'm going to close it for now. Well, I can leave it there. All right, so let's just come back up. Here's my add migration, right? Now I already have one at this point in time, so I don't need my output directory. Add one too many, whatever. So I'll add that migration. Okay. Now you see it's warning us that there might be a loss of data. Okay. Well, let's see if we can do our update database. Oh, oh, I gave the same command a second. I meant to do my update database command. Silly me. Okay, now you see we got some errors, right? Now, if I scroll back up, I see the error came into effect here. Remember I mentioned that sometimes it can just modify a table, but in this case, it was actually executing this command to insert the data into a temporary table, right? And that led to a problem because of the requirement that there has to be a foreign key value, right? Right? There has to be a mask ID specified for the existing data. So when you run into a situation like this where you can't just progressively go on to the next migration, we have two choices, right? I can do what we said before, delete the database, delete your whole migrations folder, just recreate it from your new model from scratch, right? And that works every time, guaranteed, no problem whatsoever. But of course, you lose the database. Is that the end of the world at this stage? No. However, sometimes you can come up with a bit of a clever workaround, save you doing all that extra work. So what I'm going to do is if I come in here, have a look at my database. The problem is I've got this one, one and only lonely record in here, right? If I had no data in the table, I have a hunch that I probably could get away with this. So I'm going to just select that row, press delete. Of course, I could open a query window and write delete star from whatever, right? Now that there's no data to have to worry about migrating, if I do my update database, bada bing, and there it worked. Okay. All right. So if I refresh the database now I see my two tables, mask and mask type. Okay. I'm just going to come in here. I'm going to put a bit of sample data N95. This is my categories, right, of masks, basically. My surgical mask. I can't think of a third one, so I'm going to leave it at that, right? I'm not going to worry about adding a mask in terms of sample data, but I wanted to have something to show for my mask type. Okay, so there's my migration builder, by the way. So we're in the up, right? We dropped that old column, the string for mask type. Okay, we added the mask type ID, the foreign key. We create the new table, mask types, right? Create the indexes, add the foreign key between the two, right? And notice the on delete, the restriction is in place. And that came from the Fluent API, the code we put in there. And that's it. Okay. All right. So we're going gangbusters here. Now, I could, and let's talk about this for a second. With the view, the controller and view, problem is at this stage it was scaffolded before I had this lookup value. In future, you're going to run into a situation where um, you have to either decide, well, I've done an awful lot of work customizing my controller and views and so on. So if I'm just making a bit of a change, adding a new field, I could just go in and modify the code that I've already done a lot of work on. And that would be less work than starting from scratch. However, in this situation, I've not done any customization. So I'm best to actually see, I already went ahead and did it. I deleted the controller, I deleted the views so I can just scaffold them again, right? So at this point, I can just add the mask controller back again. Make sure you choose MVC controller with views using Entity Framework. That gives me all the goods. Select mask. It'll be the mask controller once again. So the second time when I create it, it's going to look at the relationship between the two entities, right? And the fact that in our mask object, we now have this mask type object as a property inside of mask. That's why we're going to see down here in the index, look at that. We have a separate link query here first, going to the contents, asking for the mask objects, right? But, include the mask type, right? Let's go back and open this class again. See, we have this mask type object, okay? So the fact that we include the mask type, this is just LINQ basically writing a join clause in the underlying database tables and pulling in all the information from mask type, right? So it's almost like a view that is being created on the fly for us involving both tables. And then that gets into the data that we then pass to the actual view, right? Now it's a pet peeve of mine, but I can't blame the scaffolding system. It didn't have any other name to come up with, so this is what it defaults to, something like that. The best name, in my opinion, would be something like masks, right? It's the collection of masks. And sure, it's including the mask type, but that's okay. So let's just see how this looks now when I run it again. Sorry, there's a darn fly in here. Okay, let me just read this message here. Okay, I just ignored it and went away. Just about an extension that didn't want to behave, but that's okay. So we started up just fine. So here I am looking at my new page, but if I click create new, look at that. Instead of typing in the type of mask, I now have my drop-down list with my choices that I can choose. So again, $15 for the very best one I have, and it's an N95. Click create, and there we go, right? Now, if you want to change the order, by all means, feel free. You can just rearrange that, but this is just a quick demo anyway. If I click edit, once more, I have my masks. Oh, I did something. I forgot that I did it without telling you about it. So I'll show you. Notice the nice spacing between everything here. If you're running this demo at home so far, you'll find everything is kind of crammed together, right? So I'll talk about that. Remind me at the end. If I don't think of it, I'll mention, well, I better not do that because I will forget. You know me, I'm going to forget. So what I did, we talked earlier about the fact that right up here in triple W root, okay, here's where we have all the Bootstrap stuff, the library for Bootstrap, right? All the CSS and so on is here, and jQuery stuff and so on. But we also have our own, here's our site CSS and our own site JavaScript file and so on. So if you want to do any customization, I mentioned it before, you don't go into the library, right? Because you download these files from the Bootstrap site. The idea is you don't change them. You add your own customizations in your own file. So this is what I added. I added this little margin to the bottom of every form group, and that would space out nicely. If I were to take this out for a second and just save that, I'm not running, so I'll run again. I should have left it. I think I might have been able to do that with hot reload, but maybe not. Okay, gonna have to fix that next. I need to get a shortcut working here. All right, if I come into edit, see how much more cramped everything is, right? That's right on top of the button and so on. That's what I hate. I don't like that about the latest version. It didn't used to be that way, but in the latest versions of Bootstrap, I don't know. I just like to add my own bit of spacing there. So let me just come back in here. I'll undo cutting that out. Now I don't know if the hot reload will work. It might. There we did. Yeah. So now that just gives me a bit more space between each of the form input fields. So I like that a lot better. I hate to do something in the background and not tell you about it. Sorry, I digress. Okay. The more important thing to talk about uh, is what's actually happening in terms of the models and so on. So let me get back to that. Okay, so that's good. I've got my new controller for my new mask. What about for mask type, right? Well, let's deal with that then. So come to controller. We'll add another controller, again, with all the goodies for mask type, right? Don't have to change any other options. We'll just let it scaffold all the controller and views for us. Okay. So you see the index here, it just goes to context to list async, right? And that way we actually have all the data there to just show the basic mask types and so on and so forth. We'll talk more about the actions, the other actions in a couple minutes, but I just want to get this up on the screen. So I now have two controllers and still no shortcuts in my navigation system. So let's deal with that next. If I come down here to the layout, remember here we have in this header section here, this nav bar, right? Where we have our navigation links. So right now we had two, one for home and one for privacy, both in the home controller, right? So what I just want to point out, also down in the footer, there's one here for privacy as well, right? So, I don't really think I need two. So for the actual mask, I'm going to steal this one. I'll show you how to do that. So the controller, I'm going to change it from home to mask, or sorry, masks, right? Because that's the name of the controller. Action is, sorry, the action is index, right? And I'll just say masks can be the text displayed in the link, right? Now, if I want to add yet another one, I could just copy this whole bit here, put another link for mask types, index, type of masks. I don't know. Okay, so then when I run, at least I'll actually have some choices in the menu system to get directly there without having to type in the top. So there are my masks, right? Here are my type of masks, right? So if I want to create a new type altogether, we'll add that in here. Ooh, well, that's a interesting IntelliSense come up. A big bass guitar mask. There we go. All right, so now if I come back to masks and edit one, we see that's automatically added here as a choice, right? Okay. All right, we aren't going to get too in depth here, but I want to just go back to the actions for all the creates and edits that are happening here. Now that we have both entities available. So pick one, either one. Maybe I'll start focus on masks first and foremost, right? So here we are. So the index we already talked about, we're including the mask type. And that is important because let me show you in the code here for the view. If I come to the index view, right? That's the header section, but here where we're actually looping through each actual item in the model, in the data, right? The data passed in is our collection, IEnumerable collection of mask objects. Notice that to show the name of the mask is item.maskType, but that's an object, so we access its properties.name. And that's how we get the name of the mask showing on the screen itself, right? Okay, coming back to the action. All right, now there's one index action, there's one details action. Details, as we saw when we ran it, just gives you all the details laid out, just one on top of each other, right? Pretty boring. Boring at this stage because all the data, all the properties fit on the index view nicely. Details is often handy because if you have a larger entity, something with 10, 20, 30 properties, something like that. Well, you're not going to show them all as columns on an index view, right? You might pick out two or three, key indicators of information about a given entity and leave the rest off the screen. And then let them click the details link to then go and see all 20, 30 properties, whatever it is, right? All right, so that's often what we end up doing in the real world because our entities are rarely so simple as these simple ones are in our first demo here, right? So that's really what the details is all about. So you know that we're going to get the mask, but we're including the mask type again. But first, our default async that goes and gets the one and only mask that is identified by the ID. If we can't find it, we return not found. Otherwise, we return our view. Now, of course, it's smart enough to know this is the details action. So we'll find the details view inside the view folder for the actual masks, right? Masks, details. And this is what it displays then. It just uses this description list, right? Uh, with all of the uh, DT and DD elements and so on, right? And then shows all the data on the screen. Okay, moving down the controller. So we have one index, one details. Notice that we have two creates, two edits, and two deletes. By the way, a keyboard shortcut combination, good to know. If you hold Control down, press M and O together, right? That shrinks everything down, right? So you just see the first line of each action here, right? And you can go Control ML to expand it all, right? It's just a quick and easy way. So I'm going to go Control MO again, right? Just to point out so that there's initial create and a second create, right? Well, you're allowed to have actions of the same name, okay, in a class as long as the signature is different. The data you pass in is different, and that's what's happening here. This one is the default for a GET request. So when we initially ask for a create, this is what action responds to that, right? So what do? Well, we go and we're building a select list. A select list is a data structure for populating our drop-down list or combo box, if you prefer to think of it that way. It's a specialized structure, right, that actually is built just for that purpose, okay? We have to pass it, first of all, the data, right? And then we identify, you see in here, uh, the INumerable collection of items. The string is the first one is the data value field and the data text field, right? So the value field is the property in that object that is the internal value. And then the text is what is displayed. So that's the property name in this case, right? So that gets us that. And what are we doing with it? We're throwing it into that name value pair collection again called view data, right? With mass type ID, and we return view. So let's look at the create page now. Coming down here to the create, what we see, okay, the model is our mask, right? We'll just get one, but down at the bottom here, right, is our select element, okay? Now notice we're using these tag helpers, right? ASP4, okay? Mass type ID, that identifies what property it's for, right? So we have our label, so it will just automatically show the label, the display name for our mass type ID. And our select is for our mass type ID. It's form control. And the items, look at that, comes from our view bag. Now you might say view bag, it said view data. What's the difference? Well, view bag basically is view data. The only difference is it's a dynamic view of your data dictionary, right? It allows you to do typing. So view bag and view data are interchangeable. The difference is with view data, you put the name like in quotes. With view bag, you go dot, right? And then so it's like you're defining objects or classes on the fly, right? So the mass type ID is there, and that becomes the items collection inside the actual select control, right? So that's good. And then we have our inputs here for the price and the description. Notice these spans, validation for, right? Well, remember our data annotations where we gave custom error messages. Well, that's what they provide, okay, in the actual HTML of the page for this. So let me actually run this again. If I come to masks and create new, okay, if we actually have a look here and examine the HTML of the page, right? Okay, so here I've selected the price input, right? So that's why you see it here in the HTML. So let me just move this over a bit. So here's this span, okay? That corresponds to the one here in Visual Studio, right? ASP validation for description, class text danger. So this is still on our web server. It prepares HTML to be displayed in the browser. So that becomes this span, right? Data value message for price, the value message replace true, right? And then it gets the message from up here, okay? You must enter the price, okay? So all of this code is generated in HTML from the C# Razor code in the actual view itself. So that's all the data. I just want to run through it quickly. You can understand it. It's also talked about in our online tutorial. But you see in the input, it has the values, the data value required, right, et cetera, et cetera. And all the information comes from the view generated as HTML. Okay, so once again, why are there two, right? Why are there two creates? Well, that was the first one was for the get. It just basically gets the record and displays it in the view so you can make changes. So notice this annotation. If we have another request comes in for create, but it's a post, then it gets directed to this action here, right? So in this case, what do we do with the data? Well, each of those inputs, okay, will provide data in the post, in the form collection of the post, right? This is a whitelist to protect against, as it says here right in our comments, which I've hidden, to protect from overposting attack, right? That's why we have this whitelist. We're only going to bind, okay, to certain properties that are coming from the form, ID, price description, etc., right? And we only bind to those as we build our mask. That's an overposting attack is where somebody uses a tool like Fiddler. They get in between, okay, the form, the data that was filled out, and they maybe add something new. Maybe they guess that, oh, you know what? In this particular collection of data, this entity that they're sending in, I bet there's some secret property they're not letting me see. But if I can guess the name of it and give a value for it, I can insert that. And then that way I could game the system and provide invalid values, right? Maybe even do something that would allow me access to their database in the back end or, you know, steal some money or whatever, you know, nefarious purpose they have for an overposting attack. But we want to protect against that. And that's how this whitelist, that's what it's actually doing. It means when we build this mask object, right? And think about it, that's doing a ton of work we used to have to do manually. We used to write code in PHP or whatever where you take all the values, you'd go through the form collection, find each value for price, description, etc., assign it to a variable sometimes, or maybe a property of an object, right? If you're doing an object-oriented design in your code on the server side. Well, none of that code has to be written anymore. It's all handled completely by this tool, right? So we just built our mask object and that's it. We're done. Then we come down here. We can check the model state if it's valid. So if anything violates any of the validation requirements, right, then we won't even try to insert the data, okay? Uh, basically, it will just return back and to the user to fix the problem, right? If everything is valid, though, look at this simple code. We just go to the context, we call .add, pass the object in, call save changes, and then we redirect back to our index action, right? So after we've inserted the record, that's where we go back to the index and we see the resulting data, right? If it's not valid, we're going to return the create view again, right? But we have to prepare once again the view data to include, okay, the data for our select list, right? So that's why that code is repeated here. It gets sent back once more time to the view as we redisplay. And of course, this will contain any validation messages and so on that were added that made the model state invalid. All right, so I should mention that validation will be checked on the client side if the browser allows it, right? We see that all the code has been actually added to the page, but you know, somebody might have JavaScript completely turned off, right, in their browser. They don't want to allow any JavaScript. So in that case, that code can't execute on the client, right? And they will not be able to do the validation there. But when it comes up here, it does the validation. And so when it reappears on the screen, it will have the validation messages just the same as if it was validated on the client, because it's always checked again on the server no matter what. Even if it is checked on the client, it's double checked on the server when the data gets up here. So basically we have the get for create, which gets the initial. The post, HTTP post for create, is the attempt to actually do the create operation, right? If it's valid, it succeeds. If it's not, it goes back to, and succeeds and goes to the index. If it doesn't succeed, it wasn't valid, then it will go back to the client. Now, what we're not handling here yet, what if when we go to save changes, there's a database error, right? Well, that might not get communicated very well back to the client. So that's be something in our next demonstration. We'll be looking at how to improve this code so it is more robust and covers all kinds of different error situations. But let's take things a step at a time, right? Edit, again, we have a get. We identify with this ID which one we want to edit, right? As long as we actually have a value and it's there in the system, okay? Then we'll go and we'll get it, and then we'll try to update it, and away we go, right? Oh, sorry, we get it and we return it. There we go. Again, we have to prepare our view data with the select list, and away we go. Here on the post, sorry, I'm getting ahead of myself, is where we actually attempt to do the modification, right? So on a post to edit, we have the ID, and again, we bind and we build our revised mask object. Now, maybe they didn't change anything. Maybe they changed everything, right? Okay. Then we check again if we actually have an ID, if the model state is valid. Then this is at least is in a try catch, which is a big improvement over the create. But basically, we update the mask and we save changes. If there's a catch, it's already set to look for a DB update concurrency exception. Remember that timestamp business and so on, right? Now we aren't actually implementing that just yet, but the code is here in place, ready for us when we do, right? And we can add additional catches for other exceptions as well, obviously, right? And then if it's not found, if that's the problem, then we return that. Otherwise, we just throw the exception, redirect to action the index as long as everything went fine. Otherwise, we just redisplay the edit view, so any error message contained in the metadata for this will be available to display on the screen. So a two-step approach, the get and the post. It always happens on the post, right? Same thing here. That's, by the way, a general rule of web development. You should never modify data on a get request. You should always do it on a post. Okay, for delete, once more, we come and we get the record to delete, right? Make sure we actually find it. We go and we get it, including the mask type, and we return that in the view. Then with the post, okay, less complicated really. We just need the ID, okay. We actually go and we find it and we remove it. So our context.mask, that's our DB set.remove, and that will then, as we save changes, delete the actual record from the database, go back to the index. Okay, so we'll look at how we can improve this code, but hey, it works. It's basically covering most of what we have to do, and I just wanted to quickly walk through and discuss what's going on inside the controller here. All right, well, I think I'll leave off the recording there. This is, again, has been long enough. We're almost 40 minutes yet again. In our next demo, I'm not going to take this one much further, but in our next demo, we'll actually start building our medical office, and we'll be much more detailed about the changes that we make as we go through there. In the meantime, hope you find this helpful. Just my own kind of approach a little bit imposed on what you're doing in your actual tutorial.